Grace. Lincoln Christian.
Yes, definitely. I have heard many a person say that.
I know. I thought we were going to do it in class. That's what I thought. I didn't know how to do it. Yeah, I kind of just went past.
Lincoln. Olivia is here. She's late. Grace is here. All right, to start off today, I need y'all to get out the number 59 curve sketching practice FRQ that I gave to you after the test last time. If you remember, I know it's been almost a full calendar week here, but I asked you to have done parts A through D, since those parts carried over from the last unit, and that way we could look at part E. So, should be 59 in your binder. So we're going to talk about part E together so that you can see what is different. Notice I'm not calling this a new unit. Honestly, this stuff probably should be on your last test, but it's always been this way, so I'm guessing just to try to break up the material. But all the same stuff. If you know when a function is increasing, decreasing from the first derivative, if you know when a function is concave up, concave down from the second derivative, really there's just one more step to be able to get a pretty accurate graph, which is what we call curve sketching. So we're going to do the last part of this FRQ, check off 59. Then we are going to look at number 60. Number 60 is the handout you picked up that has f prime graphs, and we need to graph what the function could look like and what the second derivative would look like on that. After that, I've got and that one's quick. 61 is also quick. It's a card sorting activity. So that's the other handout that you picked up that has a little table at the bottom for you to put your answers. Obviously, I didn't give you the card sort yet. And then finally, on your desk when you came in, you should have had 4 pieces of paper. So when I copied that off, I thought the copy machine had staples, and I meant to copy it front and back, and it didn't do either of those things. So there are 4 one-sided pieces of paper that will make up the curve sketching review. So that is what we'll be looking at all day on Wednesday, but you need to get some of it done before then. So that'll be around the second half of class. You'll be able to move on to that. Okay, so from the practice FRQ, so I will ask you to turn this in between now and Wednesday, but for our sake to get to part E, I'm going to share with you the answers I got for A through D. So if you got different answers, you can go back and retry the parts that you got different answers to and correct it before you turn it in. But part A was wanting to figure out when you have horizontal tangent lines. I got -1, -3. Part 2 wanted to know when you had vertical tangent lines. Should be at 0, 0. Again, you can go back and retry these if you did not get the same answer. Part C, relative maxes and relative mins, and when they occur. Part C, we had relative max of 24 when x equals 8, and relative, sorry, not relative, these are absolute. Absolute min of -3 when x equals -1. And then part D, when is it concave down? That is between 0 and 2. So jot those answers out to the side. Any of those answers that did not match up your work, you need to redo before you turn it into Google Classroom. But all of this is what I wanted you to practice before today so that we could look at part E. Part E is the curve sketching part, and then this is really the only new thing in addition to what we did in Unit 4 before the curve sketching quiz. So we've got a lot of good information here. I can tell you that well, first off, this question only cares about -8 to +8. So we're going to make a pretty accurate graph, but it doesn't have to be perfect, so I'm just going to count those out. So from part A, this is where I found horizontal tangent lines. So at -1, -3, I know at that instant it has a horizontal tangent line. Also, that means it's a point on the graph. At 0, 0, there's another point on the graph. That is where we had a vertical tangent line. When x equals 8, we had an absolute max of 24. So up here at 8, 24, that should be the highest point on my graph. But there's another point. Also from part C, I know the absolute min is -3 when x is -1, and I didn't even plot this correctly. Y'all didn't say anything. Right there. So I already knew that point, but I know that's the bottom of my graph, so I guess if I wanted to kind of zoom in a little bit, I don't have to go quite as far down. And within working part D was when is it concave down? And so it's concave down from 0 to 2, and therefore it was concave up the rest of the time. So we've got a couple points. We know when the graph is concave up, concave down. We know the biggest point, the smallest point, and also within part C, I did a candidates test, and some of the points on here are things we already know, but one of those that I had to test was -8. It turns out -8 should be a point. So there gives me one more point for my graph. And I had 824, but I already have that on there. So curve sketching pulls in all of this, most of the stuff from Unit 4, not all of it, I guess. But if we know when the graph's increasing, decreasing, if we know when the graph's concave up, concave down, the only other thing you need to get a pretty accurate graph and call this curve sketching is a couple of points. I've got a couple of points down. So sometimes you might want to just, you know, make a table, plug in some more points. Plug in 1. I'm looking at the function because I'm using points. If I plug in 1, I would get 5. So of course, the more points that you do, the better and more accurate your graph is going to be. For our case, and for the AP test, usually they'll say, if this was like an FRQ, they might say, graph 3 additional points, or 5 additional points. Or maybe in the directions it'll say, it goes through, whatever, 1, 5, and 0, 0, and -1, -3. So it gives you a little bit more information. But I know it is only concave down from 0 to 2. So I'm going to try to make that show concave down. I need it to try to be horizontal at this instant. I know it's got to go through this point and turn around because it's supposed to be a horizontal tangent line. I found this point over here as well, so I can connect that. And I know this point up here as well. Actually, this is concave up, so I should try to make it look concave up. I know that's concave up because the only times it was concave down was 0 to 2. But the rest of the time should be concave up and concave up. So that's not a perfect sketch. The only way you're going to get a perfect sketch is if you plug in hundreds of points. That's basically what the calculator does. The calculator just throws in lots of x values, solves for y, plots the points. But this is plenty accurate for us. So basically the only thing I'm telling you is if you pull all your information we learned from Unit 4, also get yourself a couple more points, connect all of those points, make sure it's increasing, decreasing at the right times, make sure it's concave up, concave down at the right times, make sure it's horizontal and vertical at the right times, then you can do curve sketching. So, okay, that's the last part I have to say about that. So, is there anything you'd like to ask about part E before I take it away? Okay, then the next one we're going to look at is graphing f and f double prime given f prime. So this is not new information, but we're just trying to focus and get a little bit better at some of the stuff that we've been using recently. So first, let's just focus on f prime to f. Yes?
What number is this?
I don't remember. It's on the agenda. It'll be back up later. Or you can look over there. Okay. So when f prime is positive, what does that tell you about the function? Okay, so based on when f prime is positive, I'm going to try to color this to help you see. My function should be increasing. It should be going up from 0 to infinity, and it should be going up from negative infinity to -2. Now, I have no idea what y value is going up to. I just know it's going up during this time and up during this time. Okay, when the first derivative is negative, what do we know about our function?
Decreasing.
It's decreasing, so it needs to go down. So I need to make these connect. So let me maybe put it up here instead. Maybe put this up here instead. Again, there's not enough information for you to know these two y values. I don't know what it's increasing to or what it's decreasing to, but I know when it's increasing and when it's decreasing. Do y'all see the connection there with the different colors? Okay, we can come back to this and we can make this one a little bit more accurate, but let's slide over because we're going to have to put the same thought into this one. When the first derivative is increasing, what does that tell us about the second derivative? Okay, so second derivative needs to be positive from -1 to infinity. And when the first derivative is decreasing, what does that tell us about the second derivative? It's negative, so that would be below the x-axis. So that is a possible representation of the second derivative. Now again, we only know when it's positive and when it's negative. We can't be accurate enough. It could be like this. It could be steeper. It could be less steep. All I know is when it's positive and negative. So there's a little bit of estimating in there too. Okay, so go back to this one, because I said we could make this look a little bit better. This cannot be your function graph. You see how we have cusp here and here? That means that the first derivative would not exist. But the first derivative exists at -2 and he exists at 0. I can see what it is at 0. So the other thing we can do to make this first derivative a little bit more accurate is to use this information that we used for the second derivative. When the first derivative is decreasing, the second derivative is negative, which means the function is what? So we need to try to make it look concave down from -infinity to -1. So add a little bit of curvature without messing up the increasing decreasing. And then same reasoning for the right side. When the first derivative is increasing, the second derivative is positive. When the second derivative is positive, the function is concave up. So remove this sharp turn here, add some curvature to it without messing up the increasing decreasing terms. That's what we're aiming for. Once again, I'm not going to dwell on this too much, but I don't know this y value and I don't know this y value. There's not enough information for me to know these. But it's increasing at the right time, decreasing at the right time, increasing at the right time. Concavity is correct, concavity is correct. So that's as close as it's going to get.
I have a question.
Yes.
So it curves so there's no cusp. What is a cusp?
There should not be a cusp.
Right.
What is your question?
So what is a cusp?
A cusp is a sharp turn like this. You can't take the derivative of a sharp turn like that.
Okay.
Your slope can't go from this to this in an instant. It's got to be over time. It can slowly change to take a derivative. Okay, let's do another one together, and then I'll have you do the third row as guided practice. So we can get some information about the function just thinking about where the first derivative is positive and negative. So again, notice I'm not saying anything different, just looking at different questions, same skill though. So when the first derivative is positive, my graph should be increasing. So it should be increasing from 2 to infinity and from -3 to -1. Once again, I don't know the y value it's starting at. I don't know the y value it's ending at. I'm never going to have that much information. But I know it's going up during those times. When the second derivative is negative, it should be decreasing. Second derivative is negative, so it should be decreasing. So to make these connect, I need this guy to decrease. So I'm going to move this one up here, or down here. Once again, the y values are not important. Increasing during the right time, decreasing during the right time. Okay, but this could not be, this is not a good final answer. Right now I have 3 cusp. You cannot take the derivative at a cusp, but those derivative values certainly exist. I can see they exist. They're not holes or asymptotes over here. So we need to add some curvature, but to be sure we're doing that correctly, we need to think about when the first derivative is increasing, because that is when the second derivative would be positive, concave up. Till -2. So make those times concave up without messing up your increasing, decreasing intervals. And when the first derivative is decreasing, the second derivative is negative. When the second derivative is negative, it's concave down. So from -2 to +1, it needs to be concave down. So that is one possible answer for the function. Any questions about how I came up with that? Okay. Then, if we've already put some thought into the second derivative, then this one should be pretty quick to finish up here. First derivative is increasing, second derivative is positive, so that would be above the x-axis. Above the x-axis, that's where it's positive. And where the second derivative, or first derivative is decreasing, is when the second derivative is negative. And so if we're graphing the second derivative, for him to be negative, he's got to be below the x-axis. So it probably looks more like a parabola. So. Okay, copy that one down. If you have a question, go ahead and let me know. Otherwise, try the third row and see what you come up with. Okay, does anyone need more time for the function part? Because obviously we need to check it, and there's not just one correct answer here, so. Okay, then your answer for this third row could be correct if you have it increasing from -1 to 2. As long as it's going up during those times, and decreasing from -infinity to -2 and 2 to infinity. You need to make sure that your graph is increasing and decreasing at the same times, not to the same values, but during the same times, and that part should be fine. But you also have to worry about concavity here. When first derivative is increasing, it should be concave up. So that's till about, I don't know, 1/2. So it could be something like that. And then when the first derivative is decreasing is when the second derivative is negative, concave down. So add some curvature without messing up your increasing, decreasing intervals. And the function could look something like that. Yours should be the same shape. The only thing that could be different, and probably is different, is this y value and this y value. You just have to pick something, so I just picked something. There's nothing special about those though. Okay, any follow-up to this one? Okay, let me give you another moment to make sure you have the second derivative done. If you're done with it though, you can go ahead and move on. I do want you to do the last 2 rows, and I will check those off individually. Okay. Honestly, if you've already done the concavity for the function, then graphing the second derivative should just about be done, because you've already thought about when the second derivative should be positive and when the second derivative should be negative. So, something like that. Okay, I want to point out one more thing to you that I think will help you with these last 2 rows, and then help you with the card sort. The card sort that we'll be doing once I check these for you guys is very similar to this, where there's graphs of functions, graphs of first derivatives, and graphs of second derivatives, and you're basically trying to pair them up, trying to figure out that these 3 go together and which one is which. And I know we have mentioned this before, but again, I think it's helpful to pay attention to again here. Notice that whatever degree you think the function is, like this is at least a 3rd degree because it has 2 turning points. The number of turning points, or the degree, gives you a hint about how many turning points it has. The degree -1 tells you the most number of turning points it has. A degree 5 could have 4 turning points, or 3, or 2, or 1, or none. But if this has 2 turning points, this could be like a 3rd degree. So if you think about when you take a derivative and you do power rule, when you do power rule, you lower the power by 1. So if this looks like a 3rd degree, this one should look like what kind of a degree? Second, or a parabola. And then if you did the power rule again, took the derivative again, a 2nd degree would come down to a 1st degree. So do you see how less turning points, 1 less turning point each time? 3rd degree, derivative becomes 2nd degree, derivative becomes 1st degree. This one's probably a 4th degree because it's got 3 turning points. So his derivative would probably be a 3rd degree with 2 turning points, and his derivative would be a quadratic with 1 turning point. The degree goes down 1 each time. This looks like a 3rd degree, so his derivative should be a parabola, and his derivative should be linear. The degree goes down 1 each time. So I would like, oh, is there only one more row? Oh, I thought there was 2 more rows. Okay, go ahead and fill in the last row. And then while you wait for me to check that, on the other handout you guys picked, you can fill out the top part of it. I guess I don't have my copy anymore. Give me an extra minute here. I lost my paper, so I'll just do it. Okay, again, while you're waiting for me to check that, this other handout that you guys have, the top part of that you should fill out while you wait. So just answering, if you know the function's increasing, then you know the first derivative is, and then fill in what you think it should be.
So how are you does it online? Should I correct it from the person? Or do I need to
If you have
go-
mistakes, you should retry the ones.
Is it okay if I got them wrong, like, and I already turned them in? Or do you want me to read, like,
I
some?
need you to redo it.
But isn't it due today?
I fixed that. It's not, it needs to be completed by Wednesday.
Okay.
The bottom row looks good.
I see why.
I need to see bottom row, make sure it looks good. Works.
think you just went like farther out. Yeah, I did like a
So x equals negative 2, the concave expansion. So here it would be concave down. Here is just concave up. So you just have to change the inflection.
That works.
Is that correct?
I don't think I've run all the
Yep.
I don't have one.
Sorry, so that's the tough part of this.
And then they go like, It needs to be. Those are scary. I've never ridden one of those. How many did you guys so like, and you drop it like that. Yeah.
This is for when you're done with the top.
Is this correct? Yeah. This you should do it now that you're talking about it. Just makes you feel. I've done a 90-degree question.
Hey. So what do you guys do? Like on the third one, did you put equals 0 or
Yeah.
each?
They don't show the derivative. I guess you can kind of figure out this early secondary
What about this part?
This is all probably for well, probably the ones that go up down probably. Yeah, that's yours. I talked about it. Well, yeah. Whatever the slope is.
Okay, I think everyone is moving on to the card sort, so let me give a few directions here. Each card has a number on it. What makes this card sort a little bit harder and take a little bit more thought is some of these cards are functions, some of them are their first derivatives, and some of them are their second derivatives. So basically like this. If you imagine this and you cut these up into 16 cards, you have to think about which one would be the function that would go with its derivative, would go with its second derivative. So I do think it helps. Functions are going to have more turning points. Second derivatives are going to have less turning points. But every one of these cards has something to match up to. So that little table on the bottom of your page is where you need to put your answers. Just put the box or the card number. So if you think 1 is a function, put down 1 on the far left. If you think 2 is its first derivative, put 2 in the next to it. And if you think 3 is its second derivative, put 3 next to it. That's not the correct answer, but again, this one is a little bit harder because you're not being told which ones are functions and which ones are second derivatives. You have to kind of figure that out throughout the process. And then I have the answers to check with when you're done.
Positive, all three.
Shouldn't there be a difference? No, we're supposed to figure it out ourselves. So the ones that
Okay, so 7, 1,
And everything matches up one time. So if you get a few of them right, you make the last one easier to process.
focus the entire business positive.
oh, we got a second to check it. So, absolutely. This is on positive. No positive.
This will change.
That's probably right.
I think it's today.
That one has to go with the first one. I gotta make sure they're right. Yeah. Those look right. Every card we theoretically could any of these work out better.
Maybe like it has to do with the slope, because like it's like a steeper slope. It could go this way. So then,
But then maybe this could be that one. So that one.
this one changes to 2.
If you're struggling and getting started, please let me know.
Okay, so these two definitely.
Yes.
Maybe we should do flat.
I think this one actually goes positive. It's a steeper slope.
Oh, wait, no.
Probably this one might be secondary.
We're just hiding it over there. I didn't know there was a-
Yeah.
You gotta go.
That's a fine.
What if that's actually the actual?
Minus 14 equals negative 8. Wait,
Guys, you'll need to be careful with the card that you don't have them upside down. The number should be in the top left. If it's flipped upside down, you're gonna think that's not gonna match up.
I think it should work like that.
We found a pattern possibly where, so this one, 10 plus 1 equals 11.
Okay.
This one's 6 minus 14 equals negative 8. I think
Found that pattern. This one's plus, this one's minus.
well, it's
I don't think
something.
it's actually gonna work.
don't think it's gonna help us.
Okay, so
That's correct. Yeah.
I put those over there.
Equal negative 1, so this has to be well, maybe this has to be second.
So that's first group.
So, nothing for 1, no, back. These go. Oh, no, this is negative. So it could be this one. It could be this one.
This one has a minimum.
Oh, it could be this one.
Wait, how?
Yeah, I think these have to go together.
Wait, then how is this right?
So then, yeah, it has to be this. Okay. So this one is increasing. So 1/2. It's 1 positive 1/2. The other one is positive.
No, I can.
Negative until.
This one.
Negative until 1/2. It is.
Wow.
The pattern continues.
Watch us watching me fully wrong.
This kid is tweaking this. No, he's actually studying for this unit and then somehow for that. So.
Yeah.
It's like,
So these are the only options for the rest of them.
Yeah.
1, 2,
Or it's probably a.
this one is gonna have one of these. So we should analyze this one first. So.
This one's clearly, I think something like even says that stuff goes with
The problem with it that's an issue.
one day to read through your.
What years ago?
They go to.
Not for when I was in secondary.
So you let him go up top and I
They can look at this. Make it easier.
I'm sure this is the other one.
I'll just make this here.
Everything in the game.
that needs help and it's just one.
Yeah, yeah. We already established pattern does not work.
Oh, we just sat next to each other. Yeah, we did not. That was hot. Okay, never mind. Yeah, me and Trent were
There should be.
and I was saying should be Oh, are we done? I just want to check it. I might need to get water if it's not. I don't really get checked in.
No, this is.
I was pointing it.
So we need to second it. Yeah.
What's your list? It's like gamers.
The only thing is I don't know which one to this with. I don't know what you think is the function, which one. Yeah, just write them in there. Just write them in there.
This one right here.
It's just hard when you don't know like what that's like kind of pieced together. It's just a single drug. Did you see what my physics was there saying? Or something? Like, I saw in the message. I was like, oh, Capitan's tester. What the heck? We haven't done anything.
Oh my god. I'm not even here today.
Well,
That's why this happening.
I literally want to.
That's insane.
You broke our fundamental patterns. Yeah, technically we broke it.
That's fine. Just scramble these up, reflip them, and then work a few questions on the review while you wait.
I just wrote them in the order that from up to down. Hi!
This one.
I'm not
No, it's flavor like release. Like, okay, he's a guy. playing with others.
Was that it? 7, 13.
Where did you want us to put?
Yeah, it was actually.
Wait, did I need to grab the 2? Or has that hit 0 at 2 or
Yeah.
This is a lot more expecting you big.
I think that was a lot. You can look at it if you want.
It's a lot longer than
I don't
that.
want to look at it.
This has to be. So take these. So it could be used this year. This is the same.
Oh, that's good.
That's correct.
So this was right. So which one? Oh, 10, 1, 11. Is that it? So that means this is switch? Is it just
Yeah. Something else.
still between 4, 5, 8?
I think this goes to
This one is the one Let me cook. Bro, let me do something. Okay, go for it. Wait, let me check the assistant.
Is the quiz gonna be about as long as like tests? It's gonna be over so much. Or it's gonna be shorter.
Shorter than the 9 multiple choice one FRQ?
Yeah, because I'm like, that's already pretty short. So
Yeah, that's the shortest one.
that's gonna, it's gonna be.
Why do you think it would be shorter?
This is short. I didn't know if it was like.
To me, quiz just means like less new material. Test is usually like a bunch of like weeks worth of stuff. In theory, you should remember
All this.
inflection point, increasing, relative min and max.
Yeah, I assume since there's so much stuff, it'd be like the same as the test.
Is this?
What have you
It's really short. Yeah, I'd be good. I would get good. What was the first quiz we had? It was like 5
Make sure you put those on Facebook. And then after
This is the
that,
only
scramble them.
we've ever had.
We technically consider these tests as a quiz. I thought we had like half what we read. There's your question there real quick. I'm looking for 3 more cards.
Okay, hold on. And then work 2 questions on your review question.
Give me no, y'all are not allowed to do it. Y'all can keep your head out of here. I can't see the hand. Look at the shadow of the head.
And then work 2 questions on your
I got everything slightly off. Did you hear anything I said?
No, I don't know. I'm asking.
I got everything slightly off.
Nope, that's
And I just don't know.
it might be what they're asking.
I just want to see.
I don't know what they're at.
It's fine, they've done that.
What is that? Literally what?
I think it's the
Yeah, you're right.
The coefficient is going to be the same. I mean,
See, these are kind of.
I don't think I'll do it. I think I'll do the one.
Yeah, it's one of those. That's why I missed on that first time, I remember.
Yeah. Wait. No,
When? 2, 4, 6, 8, 10, 11, 12, 13. Wait, 2, 4, 6, 8, 10, 12, 14, 15.
I need a chair.
I don't know how to do whatsoever.
We need to.
I'm pretty sure whatever the degree of the denominator is greater than the top. It didn't say 1 or 0. 1 or 0.
Substitute
That
that.
was good. Yeah, we're screwed.
But I do know when it's like, when they even use divided, right?
Yeah, you just
That's the
divide the
only
leading
one.
coefficient. Yeah, that's the only one.
This is 5 or 7, right?
Yes. I'm sure about that one.
Wait, do you have your words?
It's like 7 different things.
Don't you just add it? Or, oh, you have to multiply all that.
This is max out. So you have 1. Like this one, you have it at the beginning.
We had to do.
So this one's negative.
Think in degrees.
No, this would go.
I'll check them later.
Oh, you don't hear it.
Bro, we already had that here. 4, 9, 12, 7, 3, 10, 9, 11, 15, 6, 1.
Yeah, I was gonna ask
I don't know either. I don't know either. No one knows.
Hold on,
Talk about that AP exam, be limits and
This
everything
one
else.
should
Oh,
be all.
one. Shut your mouth.
I wasn't even taught. Wait, for that. I have just moved on to number 2.
Yep, I understand.
That I missed the class last week. This is what I'm gonna do the next one.
When'd you
So behind.
When'd you miss? Oh, yeah, you were here for the test. You were here for the test. Sir, you understood like how we changed, like that, like we're like my accent is for the ball. Presentations for that.
It's really cheap. Where is? So we stored in our brain.
It's true.
Just like carrying a pencil. That's why I was so happy with you.
I think I went over there.
And I assumed you were kind of thinking.
Trust.
Bro, wait, what is going on?
Trust.
It goes.
Because look,
No.
negative look, it has a slope of 0 and -1, 0 and 1. This one has a slope of 0 and -1 and 0. It has to be right.
I speak.
Is this like our just?
My accent good? What? I think so. Well, it's not. According to Google.
What is this?
I think you just plug it to me.
I think I found something.
Yeah, I found a few some things that.
Oh, since I got the same
We get a range, so like.
How does it go from the second degree to a third?
one way, but I didn't do a third degree.
Think of it as degree.
If there's a
Like, he was telling
Pretty
us
sure
that
there's
physical
physical
perspective is like, it can be, like,
Hold on.
IT. That's like the opposite of the other points.
Hold on, I don't have
Anti-drug. We don't have a range. Yeah. So you get a, I don't know. I think that was fine.
What I just saw is I thought was
Maybe we
sure.
could at least narrow it down some.
Oh, no, I just did points, and then I just did the assigned.
But you just said that.
Correct.
Yeah.
4, 5, 8.
4, 5. Well,
I started increasing, decreasing, you can find where it's minimum maximum. Well, it does say relative and relative minimum maximum. So technically-
Correct.
So 10, I think we're supposed to do 10, 1, 2, 1.
Is it already here?
Correct.
I have to watch it.
Oh, you're good, it didn't work.
Four times this.
You check my paper, because we had like the answer to it. We had 12, 7, 9.
Minus. It's not correct.
Yeah.
Any of those correct?
Positive. Hold on.
You're fine. I'm fine too.
Negative 8, but there's already
Well, we had 10, 1, 12.
8 minus 1.
Is the X gonna be we got ours.
So you don't need to take it down?
So it's like one with
This.
Row minimum. Negative 2.
Paper. Hold the card up. Sheet paper, put down.
You slow it down.
You can say a few questions on
Things
this.
I can understand.
Yeah.
What kind of thing is I'm not trying to make fun of anybody, but I cannot understand. That should be that was give us a second. Don't even try to settle your breaking the entire question. Take those, figure out what intervals
Found out like every
Did you grow up with
You go like.
Why did you use the bottom one and
Goes
not the
up,
top?
and then 0 for just a moment, and then up. So it's basically increasing it all
The
the time.
denominator on the
Zero.
increasing?
Decreasing.
Decreasing.
Vertical line is
undefined and zeros.
Looking at the wrong one. I'm on these. Oh,
Two critical numbers.
Is yours all right? I think mine was right.
So you can try 0.
Zero, and that'd be just 7, that's
Whoa,
10 plus 1 equals 11.
Oh,
Sometimes I assume if this is negative, the next one's gonna be positive. I sometimes will do that. 10 plus 1 equals 11.
Alright, that's true.
10, 1, 11. Usually
That's true.
Yeah.
Okay, what about the left two?
9, 12, 3.
Correct.
2, 13, 7.
I'm just kidding.
Oh, come on. I'm ready to hit.
You could assume either way since it doesn't say. I would probably not assume that. I would say it goes. Either way. In a real, on your test, we would need to give you the domain, otherwise assume concave upward and concave downward. So this is the derivative. When the first derivative is increasing, the second derivative is positive. And when the second derivative is positive, that's when it's concave up. So concave up here, and here, anywhere the derivative is increasing.
Is this related, right?
That was crazy.
And when the first derivative is decreasing, Second row is negative.
I'm keeping this.
What, these? For research.
For what?
I know you did.
I can scramble them.
You did scramble them?
I don't think we did.
I don't think so, I think we just kind of. Well, it makes it harder for the next group because they think it's scrambled, but it's not, so they double guess themselves.
Well, nobody's gonna be using these until next year, so
Oh,
if I don't, if I make it that long.
I think this is the most work I've ever done.
Okay, is everybody finished with the card sort?
Okay, so
That's,
it was,
which is technically.
or it was X to
Are you leaving, Lucas?
or X to the 2.
Okay,
Trying to
so
do it indirectly.
now that you're done with the card sort, you guys should be moving on to that review. That should have been on your desk when you came in. I apologize
I
for
think
the
I-
4 pages,
I think
but
it's
again, I
4
messed
pages.
up on the copy machine and did not do front and back. That's why it looks like a lot, but
We needed times
get as much
X.
done of that as you can during class. We will have all of class on Wednesday to work on it and help out with it. And then Wednesday will be that quiz. So try to get as much done as you can. You don't have to come to class with it finished, but the more you have done before Wednesday, the easier class will go on it.
Oh.
Especially if you need to ask a lot of questions on Wednesday, you need to have time to do that. It is. But that's not one.
Oh, because it's an
The degrees are
interval.
equal. The horizontal asymptote is the denominator.
Yeah.
The ratio is equal to leading coefficient over leading coefficient. The degree of the numerator is bigger.
You guys have been Are you guys not?
It is different
Yeah.
when you want to
Where are
play
you?
so.
I mean, it's just like every single question, you know, like 10 other people already done, but yeah. Try, show me where you got.
That's usually how it goes. Your parents are really Christian.
Now, there could be like 1 or 2 people like working on it, or we'll have to do it like quiet or tour.
What about you, Sherry? What's your parents? But your parents are probably Christian?
I thought like, oh, it started new, like, oh, you can show physics and go. Oh my gosh, it must be like some like, I think it's like half war and half like admission stuff. If it's like the wrong tool. That's unfortunate.
But you don't want to break it as a turning point, because if this is the first root graph that doesn't work, that what you said about where it changes is only true because this is first root. That's not a good way to learn. That's just the most thing about
Figure out how to do it.
Well, it's just in terms of the rating.
Well, yeah. What is pleasure compass? Don't try to memorize.
Like if the
I don't know.
What's the more part of this graph?
I don't know.
Yeah.
So that's just in terms of
It's on
art?
page- it's
Yeah.
on
Okay.
number 9. Or you can look at mine if you want.
I don't know, I might not be a dog, I forgot all about it, but I don't have number 9.
I have number 9. Oh, I found it.
Those are like generations.
Let me send you a picture.
Wait, you said you have these times?
Well, I guess we'll see.
Somehow, some way.
So, right.
Yeah, that was like
What is this? You want infinite?
I like that.
Limits review.
You can usually narrow it down.
Yeah, it took a lot of wiggle.
So this is everything that we've ever learned. No, it's just like the
I feel like that's only. Do we have one? I bet you there's only on your phone. I didn't have a phone on mine.
Yeah. Staples?
Yeah, good one.
Are you one of those people that likes like the mini-sided dice?
Many-sided dice?
Like, do you like the colorful like resin ones?
I mean, not especially, but I just had these, and instead of being in some drawer, I would just put them out. They make decorations, and honestly, I didn't even know I had them, so
They're cool.
if I leave them out, I might actually know to use them someday if I need them.
No, I'm just what I'm saying. Because like you can't be -3, you can't be -3, you can't be -12.
So it's increasing to 6. Below it to 8. So it's
I don't know what to do with it.
I got it. You already did some good derivative, so assuming that it's all off that.
Yeah.
it has to go.
Your numerator is bigger than denominator.
Then 32 times 12 is only
44.
I would think it'd be something like this, basically just every value is -3, or +3 and 0. Yeah, mine, no. I should probably do it.
Mr. Founder, I have a question about the review.
About 30?
No, about the review. Yeah, so would it be necessary to save this only place where I change direction code numbers? Or would this be enough to justify? That was where the only relative aspects.
I don't think it
Well,
would
those
be
might
with this
like
output
sort of
value.
change direction. You don't know for sure
It's just
until you
basically
actually
everything that's.
Well, I'm about to, but
Okay.
like, is that enough to justify if they are?
Your justification needs to be, I think, x equals 2 is the max
Like,
because
with absolute value, I don't think like.
the first derivative goes to positive to negative.
Well, they're relative, so they.
Well,
But that's still the case.
Zero
though.
is undefined.
If your first derivative goes from being positive to negative, then your function goes from increasing to decreasing. So you could say that x value gives you relative max, but your justification needs to be because your first derivative is changing from positive to negative.
So if I just drew the line thing, line chart,
That's probably not. You need to say why.
Exactly.
Why, if one of them max and one of them min, it can be different reasons.
but this
It's like
is
that.
That's not justification.
Yeah,
It's
mine
a good
has
justification
but I really
if it has, like, why I care about certain numbers, but I don't think.
I'll save the X value
But
first.
I was asking that because I just assumed that they're that. Like critical numbers are the only place where.
I think you have to talk to Mr. Equal.
What's the question specifically about that? And I was thinking, but I've never seen a question.
I think he likes all of us. I think it was like a special place in Star It doesn't like Play-Doh. It's probably been sitting in my backpack for like years. I just pulled it out just because I didn't want to waste too many of these.
I like the little white ones.
Yeah, those ones are better.
I would never buy them, but students leave them behind sometimes when I get them.
Oh, yeah. That's what I do too. I'll still pencils and stuff. What is your mechanical?
I love these because you can just use
Oh, the eraser.
I prefer these for some reason.
Those break all the time. I don't know why. I always see broken ones like everywhere.
Well, if they make them too good, then you never buy another one.
That's true.
They would make them one more better.
See, I've used them so much enough. I think the numerator is like little. This part of the thing.
Yeah. Nice.
The problem I have with this one that I just stopped using is this little part. Stop it, rotate it. They're equal. Well, they come in three divided. One round fish.
Oh, that's it?
That's it?
That's it? Whole semester? Just one semester? We sure. Seems like last year, like 2 years. What do you do? It's like in your back, like it's smashed.
Well, I think it's just because like the
I'll spin this thing on there, I'll hear the thing crackle.
The other problem with it is
You just do it.
I was doing this.
Yeah, that's
But that's either.
I'll do like that. Like spin my pencil like this. And like sometimes like I guess I'm like see like my eraser's like dirty and I don't need it. I'll, like rub my What the? I know your pen like you're like taking your fingers off your pen forever.
Limited as extra. What is why there's four look like? Four is optimal. So x approaches infinity, what y value is it? Y equals 4 looks like this. It's always 4.
Where are we getting y equals 4 from? 4 minus something?
We're just thinking of it. So as x goes to infinity, the y value is getting closer to 4. It doesn't change. It's still approaching. So that goes to 4 minus. This goes to 3 over 2.
I would
Plus. This
stand on that.
4 minus 1/2.
Just like easy power. I don't know if you just do power on
Just skip it.
There's your eraser.
I'm just gonna do.
So what you do, I don't know, I
What I was telling them, think about this as a graph. Y equals 4.
wasn't one of those oh, that's
Looks like that. Because 4, that's a graph. So as x gets closer to infinity, the y value gets closer to, it's just gonna stay 4. So that part's.
Okay. Is that good? Saying you
Yeah, that works.
Well, I did one.
We at least come on like
That's not good.
When is, how do you know if a function is increasing or decreasing based on the versus?
Well,
another line. Is it like you just exclude?
Wait,
well, I need.
I got concave down
And
around
the
there.
first derivative is what?
Which part of that?
When the function values.
Oh, I didn't read that entire.
So you need to figure out when this thing is positive.
Oh, you. Yeah, this one.
When is
Well, I
it
need.
positive?
My best friend does it.
Anything greater than 3?
Well, I need.
Yeah, more than that.
Well, I need.
What are those symbols on the
Oh,
side?
bro.
Huh?
Negative
Yeah.
2 to
No, not like a weird way, just like.
Always
that's my
positive.
friend.
Those are absolute value signs. Absolute value is always positive.
Not like
So
a-
really, you just need to make sure you know when the denominator is positive too. Just because when the first root is positive, your function's increasing. So it's trying to make it easy. It's the numerator is always positive because of the absolute value.
Oh, Dave, please go out.
So everything past 3?
Supposedly is my
What do
friend.
you mean, half is bigger than 3?
That's not what I said.
No, because 3 minus 5 is negative.
I got you.
Everything smaller than 3 would make the denominator positive. And if your numerator is positive and your denominator is positive, and your first root is positive, and your first root is positive, your function is
Zero. Here.
Does anybody still have any of the matching cards, card sort?
I didn't do this right. Go ahead. I've got 2 negative 4.
And you also have name on it?
I did. I got it. It's just
you
when I
have-
plugged it back into the equation, I get 0. I get 0 in my liability.
Oh, I really like that.
I know it is. I bet you. I did negative 4.
And you don't have to
I bet you
practice
I did
every
the.
day. We used to, but now it's like constant policy. Yeah.
I bet you I screwed the product.
Whoa, she won.
Yeah, we just look at our season.
You still have to include this when multiplying.
Whoa, like,
You just
Whoa.
did this times that.
Oh.
And you forgot this.
Oh, it's not plugging it in. Unfortunate.
Because you have to like expand it all like this. Yeah.
我喜欢吃鸡肉。
So I'm gonna do the Argentine
You want me to
one.
take your phone?
No,
But there might be like an I just don't want to sit out of it.
No, when the first root is increasing, the second root is positive. So this second root is positive. First root is increasing.
Add all that stuff up.
The second root is negative. First root is increasing. Yeah, that's exactly. The inflection point is the point where contact.
Oh, that bird gets you.
Typo or lane?
Saying when x is negative 2, and when x is positive 2, y is 1.
Oh,
So they're giving you 2 points. And then the third temperature. So that part of your graph should be actually. Okay, guys, we've got about 2 minutes, so you need to find a stopping place. Again, you do not need to be finished with 62 when I see you on Wednesday. But the more that you have done, the more questions you have ready and identified, ready to ask, the easier and more efficient content will be. Do as much of it as you can, please.